Hello everyone. So in this lecture we will study about the specifications of the sensor and transducers. So we know we can classify the sensor or transducer according to specifications also. So sensor and transducers or measurement system are not perfect systems. We can't say that sensor or any measurement system is perfect. There may some error may occurs. So a design engineer must know the capability and shortcoming of a transducer or measurement system. Suppose we want to measure any quantity, so design engineer must know what are the shortcoming of the tools or devices that he is using for measuring the quantity. So he must know the shortcoming of the transducer sensing elements or measurement systems. Performance of a sensor, transducers or measurement system depends upon a number of parameters. So the performance of overall measurement system which uh, indirectly depends upon the sensor and transducer depends upon the number of parameters, and these parameters are known as the sensor specifications. So indirectly measurement systems performance depends upon the sensing element parameters or transducer elements parameters. Sensor specifications inform the user to the about deviations from the ideal behavior of the sensors. So sensor specifications tells the user how our sensors output is behaving, means how much it is deviating from the original value. So first specification of sensor is range. The range of a sensor indicates the limits between which the input can vary. And example of the range is given as thermocouple, which can be used for measuring the 25 to 225 degree Celsius temperature. So the range of this thermocouple is 25 to 225 degree Celsius. So it can sense a temperature range of 25 to 225 degrees Celsius. Span is nothing, it is an alternative to range. So span definition is the span is it is the difference between the maximum and minimum values of the input. This is our minimum value of input and this is the maximum value of input that a sensor can sense. So the span is the difference between these two values. The difference between these two values is 200 degrees Celsius. So this thermocouple sensor has a span of 200 degrees Celsius. Next specification is error. Error is nothing but it is the difference between the result of measurement, what you are measuring, and what is the outcome of your measurement, and the true value of the quantity being measured. Suppose you are measuring temperature uh, temperature of 29 degree Celsius and you are getting a reading of 28.9. So how much error it has? It has zero point 0.1 degree Celsius error in it. So error it is defined as the result or difference between the two things. First is the what you are getting after measuring and what is the actual value of that measurement. And example is also given here, displacement LVDT. Suppose LVDT is measuring displacement and it is giving value of 29.8 mm. Displacement measuring value is measured value is 29.8 by the LVDT. But if the actual value of the displacement is 30 mm, then there is an error of minus 0.2 mm occurs in the measurement. Next definition is accuracy. Or next specification of sensor is accuracy. Accuracy defines the closeness of the agreement. It defines the closeness of the agreement between the actual measurement result and the true value. Means how much close your measured value uh, goes to the true value. It is often expressed as a percentage of the full range output or full scale deflection. An example of this accuracy is, suppose a piezoelectric transducer. It is used to evaluate dynamic pressure. It is used for measurement of pressure phenomena with explanation or any other pressurized devices, and it can detect pressure between 0.7 kilopascal to 70 megapascals. So if it is specified that the accuracy is about plus minus 1% of full scale, means full scale here is 70 megapascal. The maximum value of that piezoelectric sensor is or transducer is 70 megapascal. Then plus minus 1% of this 70 megapascal is plus minus 0.7 megapascal. So your reading must lie within this range, plus minus 0.7 megapascals. Then it is said to be accurate. Next specification is sensitivity of transducer or sensor. So sensitivity of a sensor, it is defined as the ratio of change in output value. So how your output change in your output value of a sensor to the per unit change in the input value, means as you can see that sensitivity may be defined as dy upon dx. Dy means change in output and dx means change in input. So uh, we can clear it through this example. For example, a general purpose thermocouple. We have a thermocouple may have a sensitivity of 41 microvolt per degree Celsius. Means here, if you will change a temperature of 1 degree Celsius, you can get deflection of 41 microvolt in your device. So sensitivity is defined as the ratio of change of output to the ratio of change in input. Next important specification for the sensor or transducer is hysteresis. The hysteresis, it is an error of a sensor. It is defined as error of sensor. And how we can find the hysteresis of a sensor? It is the maximum difference in output at any measurement value within the sensor specified range. That value must be lie between the specified range when approaching the point, first with increasing and then with decreasing the input parameters. We can clear this term by a diagram. Suppose this shows the hysteresis error for a thermocouple. Thermocouple is used to sense the heat, and according to that heat it will provide us a temperature in Kelvin. So firstly we will increase our input or increase the heat value from a particular input value to the specified range. So when we will increase the heat, then it will give some temperature values, and we will plot this curve. And then again we will decrease that particular heat from higher value to lower value, from this B point to O point, and then we will get again a temperature curve here. So suppose we want to uh, find the hysteresis error at this input. So the difference between both these values is known as hysteresis error, and it is an also important parameter for a sensor. Next specification for the sensor is the resolution. Resolution, it is the smallest detectable incremental change of input parameters. Means that a sensor can detect a smallest incremental change in the output signal. So uh, for example, if a LVDT sensor measures a displacement up to 20 mm, so We suppose we have a LVDT sensor. LVDT stands for linear variable differential transformer or transducer, and it is used to measure a displacement up to 20 mm. And up to 20 mm displacement, it can provide a number between 1 to 100. Then this 20 mm is divided into this 100 1 to 100 scale, and we will get resolution of 0.2 mm. Means if you will change a 0.2 mm displacement can change a number from one significant figure to another significant figure. Means it can detect an incremental change of 0.2 mm displaced object. So this is also another important specification. Next is the stability. Stability, it is the ability of a sensor device to give same output. Stable means same output when used to measure a constant input over a period of time. Our sensor is measuring the output, measuring the input, sorry, measuring the input, and that input must be constant, and then our sensor must give same output irrespective of time. Means suppose our sensor is measuring temperature at day 1, and suppose then it is again measuring we are measuring the temperature again at day 7. If we have the temperature of the room is constant, so it should give same output. So this is the stability of sensor. Sometimes term drift is also used to indicate the change in output that occurs over a period of time. It is expressed as the percentage of full range output. Sometimes we can use drift instead of stability. Next specification is dead band or dead time. So what is the meaning of this dead band and dead time? Dead band or dead space of a transducer, it is the range of input values for which there is no output. Suppose we want to measure displacement up to 20 mm, and our LVDT will not respond up to 5 mm. So that dead band is of up to up to 5 mm. Or we can say that dead time of a sensor device is the time duration from the application of an input until the output begins to respond or change. Next two specifications are also very important and somewhat they are related to each other. First is the repeatability and the next is the reproducibility. What is the meaning of repeatability here? Repeatability describes the closeness of output readings when the same input is applied repetitively over a short period of time. So we can say that repeatability and reproducibility defines the closeness of output readings. How much your output readings are close when the same input. We are using here the same input. In both the cases, we have same input at the sensor, but it is applied repetitively over a short period of time. In case of repeatability, we have same measurement condition, same instrument and same observer, same location and same condition of use is maintained throughout. But in case of reproducibility, we can change the method of measuring, we can change observer, we can change instrument, we can change location and conditions. So we will see how much the output is close to the reading. So in case of both the terms thus describe the spread of output reading, how much your reading is output reading is spreading for the same input, and this spread is referred to as repeatability. When we will say that it is repeatability, if the conditions remain same throughout the process and everything must be maintained throughout. But if we changing the conditions, then this the same term is known as reproducibility. So these two terms represents the precision of your sensor or device. And the last specification is response time. Response time describes the speed of change in the output on a stepwise change of the measurement which you want to measure. So if you will change measurement in stepwise manner, then it will shows how your device or sensor is giving response to its input. Or you can say that it is defined as a rapidity with which a measurement system responds to change in measured quantity. It gives information about how fast your system reacts to change in input. So indirectly, uh, it gives how it describes the uh, fastness of your system to for reaction of the for to react the different inputs. It is always specified with an indication of input step. So you must have uh, input step for specification of this response time, and the output range for which the response time is defined. So this is all about the specifications of sensor and transducers, and these specifications are common to both the sensor and the transducers.